Here's a math counts challenge problem. The problem says the ratio of girls to boys in the 7th grade in middle school is 3 to 2. There are 134 boys in the 7th grade. What is the total number of students in the 7th grade? So the most important things to note is that we were given the ratio of girls to boys, and that's 3 to 2. So of course that's given, and we know how many total boys there are. The tricky part of the problem is they're not asking us how many girls there are, they're asking us for the total number of students in the 7th grade. So the question becomes, how do we solve this problem? All right. Well, first we have to understand what a ratio means. And one way to think about that ratio is to think about the smallest class we could possibly create that had a ratio of 3 to 2. That means for every 3 girls, there are 2 boys. So if we were creating a class, let's imagine there were no students, but we had to satisfy this condition that there were 3 girls and 2 boys, then this is what it would look like. We would have 3 girls and 2 boys. And so for every 3 girls, there are, of course, 2 boys. And this class would have 5 students in it total. Okay? Now, to maintain the ratio of 3 to 2, every time we add a student, let's say we add 1 boy, then to keep this ratio the same, we're going to have to add another boy and 3 more girls. So you can think of it as adding groups of 5 to the class. And every time you do that, you have 3 girls in your group of 5 and 2 boys. That's the only way that you can maintain this ratio of for every 3 girls, there are 2 boys, or for every 2 boys, there are 3 girls. So we can imagine multiple copies of this group of 5. It would look something like this. Girl, 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 boy, boy. Girl, 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 boy, boy, and so on. Okay, and it becomes clear if we just start counting up the students. In the first row, you have 5. If you add in the second row, you'll have 10 total students, and then 15, and then 20, and so on. And so it becomes obvious that the total number of students has to be a multiple of 5. All right. So in this case, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 sets of 3 girls and 8 sets of 2 boys. So that gives me a total of 24 girls and 16 boys. And if we make this into a ratio, you can see that that simplifies to 3 to 2. Well, now we can imagine, we know that boys come in groups of 2, and we have 134 boys in the class. And say, well, I know there are 134 boys, and they come in groups of 2, so I can think of that 134 divided by 2, and I know what that is, that's 67. Okay? So there are 67 groups of 2 boys. Boy, 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 boy. We have 67 of these. This is the first one, the second one, the third one, and we would have 67 of those. Okay? And for every pair of boys, how many girls do I have? Well, I have 3. And I can do that all the way down the line. So if I want to know the total number of students, I can see I have 67 groups of 5 students, or 67 times 5. And that is 60 times 5 is 300, and 7 times 5 is 35, so that's 335 total students. So this is one way to solve this problem using ratios. So the important thing to take away from this problem is when you have these ratios and they're made up of 2 sets of things, in this case boys and girls, but what you're interested in is the total, that the sum of the 2 numbers in the ratio becomes really important. 3 plus 2 equals 5. That number becomes important because that helps me figure out how many total things there are in the set. So just one way to solve this problem. There are a number of different ways. We could have set up a proportion as well, but I kind of like this way because I think it's important for students to kind of develop a deeper understanding of what the ratio is and how it relates to the total number of things. And actually, once I know that, I can create other ratios. For example, what about the number of boys to the total number of students in the class? Well, that ratio would be for every 2 boys, there are 5 students. And the number of girls ratio to the total would be every 3 girls, there are 5 total students. Okay? So those ratios come in handy too. And these we could even convert to fractions and say, well, 2/5 of the class are boys and 3/5 of the class are girls. And that'll come in handy in some more complicated ratio problems in the future.